I was an undergrad getting close to finishing, and my advisor came to me and said, like, hey, you guys should do this like Indie Autonomous Challenge thing. It's this really cool university challenge, and you guys being our robotics club, you guys have done like all these international competitions before. And I said to him, I said no, because this is insane. It's insane to think about, like a race car like going at really high speeds like autonomously. That's just insane to me. He convinced us like what's the worst that could happen. We bought the car, we like raised all this money, made this happen, crashed into the wall at IMS at 69 miles per hour, and then like we were passing Hawaii at 150 something miles per hour. That.
The world around us is changing faster than ever before. Ideas once only imagined in science fiction are becoming a reality. Throughout the course of our amazing 23-episode season, we'll speak to some of the greatest minds in robotics and artificial intelligence to discuss the groundbreaking work that's fueling it all. I'm your host, Ryan Marine. Join me and my co-host, Paul Mitchell, the president of the Indie Autonomous Challenge, and see why we call this the Inside Track. This week on the show, Andy Saba tells us about the amazing journey of a group of students who started out in a small robotics club and ended up building a fully autonomous race car for the Indie Autonomous Challenge. Andy is a leader and a mentor for the MIT Autonomous Racing Team from the University of Pittsburgh and Massachusetts Institute of Technology. He shares the story of leading this group of primarily undergraduate students all the way from a few lines of code to a full racing technology stack. We'll hear about the challenges they faced building their team and why bringing undergrads into high-level robotics is so essential. This is part one of our conversation with Andy Saba. Andy, great to see you. Wonderful to have you with us on the program. What have you been doing since we saw you last out at Las Vegas Motor Speedway?
Yeah, so been working hard, taking classes, getting prepared for Monza.
Busy time for
Yeah.
sure. And with so much excitement about the new challenge of going left and right for the first time with the Indie Autonomous Challenge, right?
Yeah, this is the first time we're going left and right. It's the first time we're going clockwise. It's a lot of firsts, so it's exciting, and thankfully the car handled it just fine.
So Andy, when you guys found out that we were planning to transition to road courses versus just continuing to push the oval format, which I think we could have done, right? IAC could just say, hey, we're good at running on ovals. Let's do it more. Let's add a third car. Let's go faster. Fans certainly enjoy it. What was your reaction from like a team standpoint, and like how does this challenge differ road courses from ovals in terms of how you prepare and plan for it?
Yeah, it definitely. If, for example, the IAC would have just said, okay, let's do an oval with 3 cars, the challenge becomes more of like, okay, detecting and handling, more than one other car at a time on a track. So that is a very different challenge than saying, okay, the car now needs to be able to slow for corners, make right turns, make left turns, and make aggressive turns. These are very different challenges. So for us, it was an exciting moment because we focused a lot on in our development on really getting really well at the multi-agent interaction with 2 cars at a time. And there's a lot of approaches that we take in our stack that takes advantage of the fact that we're on an oval, right? There's a lot of simplifications you make, a lot of assumptions you make, and with a road course, you can't make those assumptions anymore. Everything starts to your assumptions start to fall apart, and you need more advanced techniques. So for us, it was definitely a oh crap moment. We have until June to make this happen. But at the same time, it was an exciting challenge to really, push our existing stack even further and seeing, how can we tackle something a little bit different. So we've done oval with 2 cars, right?
Right.
There's oval with more than 2 cars, and then there's road courses with 2 cars, and then road courses with more than 2 cars, right? And I think like the first step of even just doing a road course is a challenge on its own. And then hopefully the multi-agent part of it we should be a little bit more comfortable with that now that we've done, really high speeds on ovals with multi-agent.
What percentage of your existing code is still valid, making that switch from what we saw on the oval in Vegas to your first time on track at Monza? And how much did you have to create specifically for that new challenge?
Actually, very little.
Hmm.
That's something that like is has been kind of a little bit of a surprise, but also kind of not. So the thing that we were most worried about is our controller. So the part of the stack that says, okay, I want to follow this race line. Let's say I have a race line that I want to follow, or if I, have another car and I want to drive around them, right? So the part of the stack that says, okay, here's where I'm at in the world and here's where I want to go. How do I steer and how do I control my gas, right? So that is a very core piece of the stack. It is the thing that is ultimately controlling the car. Everything else is providing information to that piece to ultimately make that final decision. And initially, I mean, we were a little concerned that, okay, our existing controller might not be able to handle a road course. But with some tweaks and some changes, it actually does a reasonably okay job. It's not perfect. There's some edge cases where like it definitely could do better, and it required a lot of like tuning to get it to a good spot. We are working on our next generation stack that will hopefully allow us to really push for the same performance that we see on ovals on a road course. That's what we're striving for. We're trying to shoot for, okay, can we go 150, 160, 170, 180 on a road course, right? So far we've done, like 80, but we still got a long way to go.
And thinking about your participation in the Autonomous Challenge, and you're very much a student. You started out as an undergraduate student that was part of the team. You're now working on an advanced graduate degree. Kind of, what is it about the IAC and the participation in this particular collaborative project that is different from your other colleagues and student experiences, and sort of what has that meant to you as you develop and progress through your studies?
Yeah. So I mean, for me, it's kind of twofold. One is that it's just really cool having a race car. It's really cool, like writing code for a race car, watching it go really fast, and these are like full size things, right? And that is honestly the coolest thing about the IAC, right? Like IAC could have said, okay, let's do electric race cars, or let's do like go karts, right? No, let's like push the state of the art with full size human size race cars. And I think that is like the thing that is just so unique about this challenge, and nothing like it exists. And so for me, that was also the most exciting and terrifying part, because when I first started the project, like you said, Paul, I was an undergrad, getting close to finishing, and my advisor came to me, my undergrad advisor, and said like, hey, you guys should do this Indie Autonomous Challenge thing. It's this really cool university challenge. You guys being our robotics club, you guys have done like all these international competitions before. And I said to him, I said no, because this is insane. It's insane to think about, like a race car like going at really high speeds, like autonomously. That's just insane to me. But he convinced us like what's the worst that could happen. We bought the car, we like raised all this money, made this happen. Crashed into the wall at IMS at 69 miles per hour. And then like, we were passing Hawaii at 69 meters per second, that's like 150 something miles per hour. That's like where we've come and the journey. And for me, like the thing that, the initial thing is like, hey, this is really cool, is really exciting. But the thing that kind of has like kept it going for me is that a race car is like the most exciting thing that you can is this really cool thing that you can get students excited about. And for our team in particular, a lot of our members are undergrads. The majority of our members are undergrads coming in with no experience,
Hmm.
and they go to University of Pittsburgh, which is, I mean, it's a good public university, but it's not known for robotics. And a lot of these students, they didn't know they wanted to do robotics. They didn't know that they liked, AI and machine learning and controls and all of these interesting interdisciplinary fields. And they came on our team and they got really excited because it's such a cool problem. And then it was really easy for them to just kind of get sucked in.
Yeah, Paul, we've talked about this before. The race car is a vehicle, and that's true in the most literal sense, but it's also a vehicle to promote ingenuity. It's a vehicle to attract the kind of interest that Andy is talking about. And if it hadn't been something so visceral, something that had real stakes attached to it, would the level of interest have been there for you and for the rest of the folks on your team? It sounds like perhaps that wouldn't have been the case.
No, I definitely don't think so. I definitely don't think so. I mean, I've seen it time and time again where, people join our team and, they have like some level of interest, but like classes are more important and, they don't pull the all-nighters working on the car. And then one of the unique things about our team, MITPIT RW, is that we allow everyone, if you want to come field testing, if you want to go out to Indiana, go to Indianapolis and like test the car in Lucas Oil, I mean, and get stung by 1,000 bees, you're more than welcome to. But the second that people see the car, it's like night and day in terms of their involvement and their motivation level. You'll have students who, have been just around, coming to meetings. They'll like, have like a few lines of code here and there. The second they see the car and they see how real it is of, their code running on this amazing platform, you can't get them to stop doing the all-nighters.
So one thing that we've been talking about through this podcast series is the role that AI plays in the Indy Autonomous Challenge, but even more broadly in mobility, and even more broadly than that in society. I just heard you talking about kind of the pride that you and the other team members take in your code coming to life in the form of these race cars and the AI drivers that are behind the proverbial wheel. Can you talk a little bit about kind of literally the personality of that code and the way in which your AI driver for MITPIT RW is different from, say, the AI driver of the team from Technical University of Munich, or you guys were up against the AI tech racing team of Hawaii and Berkeley and some other universities. Kind of, what is the actual personality? Because I think people assume that everyone is trying to write essentially the same code to solve for the same exact problem, and therefore perfection would be all the cars operating exactly the same, passing each other the same way. And that clearly is not the case. Just like motorsports, you have different personalities and different risk tolerances of the drivers. How does that come out in your all's code from your perspective?
It's interesting. I've never really thought about the personality of. So we named our car Betty, so I'm just going to refer to her as Betty. But after the late Betty White, and definitely, I mean, compared to the first year, she's a little bit more conservative. Like, yes, we're always willing to like push to really high speeds and whatnot. But Betty, even though she has a really good understanding of the cars around her, I will say probably our biggest strength is our ability to see the other cars. I think that is one of our like secret sauces that works really well. Betty tends to be a little more conservative, give a little more space where needed. If you notice, like during the event, we always take a very very inside line, just to give the other agents more space, because ultimately, I mean, in this competition, survival tends to be the deciding factor, right? And in our case, it was the amount of fuel, but it's a matter of just making it to the higher speeds. She tends to sit back and watch and make her moves when she feels that it's right. Um, but hopefully, I mean, we're working on giving her some new spice that will hopefully allow her to be a little bit more aggressive.
Well, to that end, is Betty's personality on a road course different than it is on an oval, or is it too soon to say?
It might be a little bit too soon to say, but she definitely took to Monza pretty well. That was actually one of the surprising things. Yeah.
When you think about um, the role that AI plays in your studies and the kind of discussions that I'm sure have to be happening on campus with, Chat GPT and all these other kind of learning based AI tools coming about. And yet here you are applying um, AI, machine learning, kind of advanced robotics to a use case of a race car and mobility. Um, Kind of how much is the discussion that you guys have about the way what you're contributing and what it means to the future of mobility? Or do you even have time to think about that? Do you just simply think about the next competition, the next run, just kind of trying to understand, the mindset of a team member? Do you have time to step back and think about the bigger picture and how you're contributing and what that will mean, throughout your career 10, 20 years from now?
Yeah, I will say we're kind of at the stage with a lot of the technology where the problems aren't, do you have the best language model, right? Are you using GPT-4 or GPT-3, right? Our problems are more tangible than that, right? Our problem is that, okay, does the trees get in the way and you lose GPS, and like how do you make a robust system around that? So one of the, I guess, like, this is a more philosophical answer. One of the things that I really had to learn a lot as a researcher, when I started my master's, was understanding like where's the right places to like focus your attention, because there is so much right now, right? Like right now, there's just an explosion of advancements, and it's really easy to just kind of like your head to just spin. Like, okay, oh wait, should we be using this? Should we be doing that? Should we be doing that? And that definitely was like early on in our team. We definitely had a little bit of that head spinning, and the things that we were focusing on. But what's really good about a competition, and what's like really grounding about it, is that there is a deadline. There is a set requirements that you have to do, and that is a really good motivation for really grounding the approach and really focusing on what are the problems that we're actually trying to solve. So, in there's a lot of fantastic tools that are being developed right now, right? And I think of ChatGPT as a tool. I think of these generative models like Stable Diffusion and all these really great advancements. They're just tools, right? We haven't quite found the problems though for mobility, for autonomous racing, that we can apply those tools
Mm.
to. And I think um, the way you advance the field is you can't think of things in terms of, okay, how do I use this tool? It's what are the problems, and is this tool the right
Mm.
tool to solve that problem?
And if not, presumably, then how do you craft that tool, right, to continue to drive this forward?
Yeah, that is a very like real question, right? And that is fundamentally what advanced research is all about. It's all about like taking your problem, simplifying it down to the essence of like what are the problems, right? So for Monza, the the problem statement that we came to is, how can you go into a corner at very high speeds with another agent in front of you and come out of that corner either in front of the other agent or in a position to successfully complete an overtake. That is the problem, right? That we're trying to address, because it's there's multiple levels to it, right? You have to be able to handle corners. You have to be able to right corners, left corners, tight corners. You have to be able to handle, okay, what is this agent going to do, right? On an oval, it's a lot simpler, right? On an oval, you say, okay, they're probably going to follow the race line. right? For a corner, there's a lot more decisions about what they can do. And so there's a ton of like sub problems to this like overarching problem. But for us, it's really grounding. It's really useful to have a grounding problem to focus on rather than just focus on all of the really at this point it's kind of noise, right? There's going to be always new
Mm.
things, but until you have a problem to apply it to, it's not useful to you.
Yeah, it's just a shiny new object that may be a distraction more than it is a part of your solution. When when you think about the pioneering work that you and the other teams have been doing in this field of high speed automation, right? In excess of 100 miles an hour, multi agent. And you think back to probably, I guess, a couple of generations before you. We're talking to Sebastian Thrun, who won the DARPA Grand Challenge, and there it was about low speed, kind of level 5 navigation in a desert where the terrains are completely different. And I think the winning team was averaging speeds of 19 miles an hour. And from that, we saw a lot of work in this kind of urban, suburban, low speed robotaxi as the focus of a lot of the institutions, including, where you are now at Carnegie Mellon's done a lot of work in that. Do you feel that you guys are working on a new field? Do you feel like a pioneer where instead of, further perfecting the low speed urban suburban robotaxi use case, you're tackling this use case of extreme high speed automation, and where do you think that goes in terms of the connection back to inevitably back to mobility, back to passenger safety on highways?
Yeah. I don't know. I never really thought of ourselves as pioneers. I think because so much of what we rely on, is just learning from what has come before us. If we were pioneers, that's just because we're like standing on the shoulders of the true pioneers. But I will say I think like kind of where the high speed autonomy kind of fits in is I think it's a really good vessel to develop solutions to problems that are maybe not relevant in the 90% case for passengers, but more in that 10%, right? So in the context of self-driving vehicles, there's always this talk about the last 10%, right? How do you get a system to work 99.99999 to infinity percent of the time? And part of that is you need to be able to handle, very fast moving objects. You need to be able to handle snow. You need to be able to handle ice, right? A race car driving at the limit, right? At 180, 190, 200 miles per hour, that is not much different than a passenger vehicle driving on black ice, the way that the handling of the tires. So the things that we are developing, I think, are very applicable to that last like 10%. I don't necessarily think of it as a totally separate thing because so much of it is the same, right? We deal with a lot of the same problems. Maybe like we deal with the same problems, but kind of to an extreme. A lot of these self-driving car companies, they develop their own custom hardware, they develop their own cameras, their own lidars, so they're able to have dedicated compute. They don't have to rely on commercial off the shelf parts put together into a platform. They also have significant more engineering resources, and they also have a little bit of a larger time budget than we do, right? We have to make decisions. We measure latency in the order of microseconds. They can maybe get away with a millisecond, right? At least they will say that they're targeting the microsecond because obviously faster reaction time is always better. But for us, it's not a matter of like a safety case. It's a matter of, does it work at all?
That was part one of our conversation with team leader and mentor Andy Saba. Andy's passion for motorsport and robotics is something everyone can aspire to. Join us next time for the rest of this incredible conversation where we talk about Andy's philosophy of teaching students to explore the thought process behind decisions and not focus solely on a deadline.